Good afternoon. My name is Alex Snyder, and I'm pleased to welcome you to this already third joint seminar with Eurofins and Würth Elektronik. Today's topic is wireless power transfer and Qi testing. Today's speakers are Glenn Konings. He's a test coordinator from Eurofins. He will take care of the second part of this presentation, and Sam Som, he is division manager for wireless power transfer at Würth Elektronik, and he will kick off this session. As said, my name is Alex Snyder. I'm a field application engineer working in the Netherlands and sometimes also in Belgium. And I will start to hope to answer, pronounce all the questions you might have. It's a wrong word, but no matter there. So how is today going to look? Like all our seminars, you are muted. That means that you cannot speak, but you can write to us. We have a Q&A session available at the bottom right side of your screen. Depending on your language settings, it might call a little bit differently, but in English it's a Q&A or a V&A in Dutch. And you can write down all your questions there. After the seminar, we start asking them to the presenters, and hopefully they can provide us with a satisfactory answer. If not, because we run out of time or whatever the reason, of course, we come back to you later via email or phone call to answer the question that you have asked us. If you run into any problems, just give a shout out via the chat or give us a call. As you could heard, we are going to record this session. That means that you can watch it back later on our YouTube channel. And of course, you also will be able to share it with any colleague that was not able to attend today, but might find this also interesting. Total time is about 1 hour, plus minus a few minutes maybe. We're going to integrate a live demo, so that's always tricky time-wise. So please forgive us if we're a bit overdue with a few minutes. And then, of course, at the end, we have the Q&A session. So just to give you an indication of what we're going to talk about, Sam Som for Würth Elektronik is doing a small introduction to wireless power, the difference between inductive and resonance coupling, and we'll talk a lot about applications, and we'll also give a live demo. And Glenn Konings will talk more about the Qi, the standard, the testing about it, the specification, how to test, and what kind of troubles you might run into if you are going to test your application to apply for a Qi certification. So that's what we're going to do today, and that will end my role. Sam, I will pass on presentation to you. It's done now. So I will want to wish everyone a good presentation, and Sam, good luck.
Thank you, Alex, for these welcome words, and appreciate this to be part of this webinars. And yes, I will try to start directly with the presentation. So let's try to share my content. Okay.
Yes.
I hope this works, Alex. Also,
It works
in the presenter mode. Oh no, this is not correct, and we have to just change slideshow. And then go here. Yes, now it works. Good. So welcome to the wireless power transfer enables IIoT session. We cut the cord. As Alex mentioned, my name is Jem Som. I'm responsible for the division of wireless power transfer at ISOS globally. Normally, if we're talking about wireless power transfer, everybody is thinking about what is possible and which parts, which electronic devices we would like to power. But first of all, I would like to show you a strong, let's say, family. This is, let's say, our Würth group, and I think most of the people knows this. So our privately owned Professor Würth here on the left-hand side in the picture, we have around about 80,000 employees and more than 400 countries in 400 companies in 80 countries. We, as a Würth Elektronik group, are, let's say, more or less 10th of this total Würth group and 3 business units. And we, Alex, and the other Würth Elektronik guys from the passive components, we located at the ISOS group. So very shortly, And maybe a first picture out of this is, you can see this is a drone from a company nearby Munich, where I am located, is called Quantum Systems. They provided me with this kind of drone. Later on, I would like to show you why. But just give you an idea, everything here is wireless, like Wi-Fi, Bluetooth, GPS, everything is directly sent over the data. Only the battery, which you can find here in the nose of this drone, is charged with some wires. First of all, I would like to give you a short introduction how wireless power works. So in principle, I think from physics, you can remember this is a transformer. If you have a transformer, you have a core around here in black, and if we cut them, like maybe with a chainsaw in this case, because it's so big, we have a primary side and a secondary side. The primary side at wireless power transfer is transmitter, and the secondary side is our receiver. These are separated with a big air gap. So this is, let's say, more or less wireless power transfer. We transferring energy not with a ferrite, we are transferring energy over this big air gap. If we place receiver and transmitter quite near to each other, the concentrated magnetic field will transfer the energy to the secondary side. They are mostly used two ways to transfer this in the market. First of all is inductive coupled. Inductive coupled, in my explanation, at the transmitter side I have a coil, and the receiver side I have also a coil. These coils are closely coupled to each other, and the magnetic field are concentrated between each other, and you can see in red lines the B field, which flows through both coils and will magnetizing this coil, and then you can catch up this energy here. For sure, as you can see here, we have a kind of stray field, but I will explain this later on, as we have a ferrite plate here as well. The magnetic field is concentrated. The other point is we can do it also in the resonant way. It means resonant is, and both are resonant, but loosely coupled. It's maybe a better explanation. And this system is working in a higher megahertz system. So this inductive coupled systems are working between, I said, 85 and 200 kilohertz. If we look into the SAE, like for e-cars, they are at 85. If you have, let's say, a mobile, like what I have here in my hand, then you can be sure it's in the range of 150 kilohertz. The loosely coupled system is working, for example, as 6.78 megahertz, like for the Air-Fuel Alliance. And then I'm talking about antennas. In my, let's say, explanation, if I'm talking from antennas, we have an impedance matching, an RX, a receiver antenna, or two, and we have a very, very loosely coupled system, which is connected, maybe with this here shadow, which I included here, but we have much more freedom in X, Y, and Z direction, but in the other way around, a higher stray field and a bigger field outside and not concentrated between these coils. In our next foils, in our next, for the rest of the session, we are always talking about inductive coupled, closed coupled systems. So what I would like to show today, first of all, different kind of applications which you can use industrial Internet of Things up to 200, 400 or much more watts. As a basic for our industrial Internet of Things, we have our 200 watt up to 200 watt kit, some added values. I would like to show you the LCD board, which gives you an enabling part for IIoT. And this IIoT I would like to present, as Alex said, in a live demonstration. Hopefully it still runs on my desk right now, so let's cross the fingers. And a proof of concept, as I mentioned, the drone. And for sure, in the end, our support. But important is, from my side, how to include or implement the wireless power technology in your application as easy as possible. Okay, what kind of applications do we have right now in the market or could be possible? So for sure, lawnmowers, drones, as I mentioned, or some kind of power tools. Maybe also my laptop. There are some from Dell and from HP they're working on. Also some agricultural robots which can drive around and measure with their sensors humidity, temperature, and so on. Additionally, you can have in the inner cities charge your scooters or bikes or maybe kind of caddy cars or wheelchairs, forklifts. So from very low power means in this case maybe a lawnmower about in the range of 50, 100 watts, 150 watts up to several kilowatts. I did this in my, it's a 1-year home office. Maybe in the free time, everybody did a different kind of things in their own projects. So one of them was I get in touch with the company Quantum Systems, and they borrowed me this drone. This drone, it's quite big. So the size here is 2.5 meters, and you can completely deselect them and then put it in a huge case. And here is the battery, and there is the possibility to put some kind of cameras or other measurement instruments. So in Zoom, this looks like, in this case here, is the possible to do a payload. So how this looks like. You can see at home here we have the drone, which I built up. And I built this up at home and to try to show and to implement wireless power transfer. So our wireless power kit include in the payload side, and this is the transmitter to transfer the energy. If it is included in the drone and the drone will land at a specific spot, this is very easy to program. It's possible to charge wirelessly. In the payload, you can see I placed the PCB and also my the ferrite, so the coil, and here we have the battery management. So in a little bit zoom way, you can see I cut out here and placed the coil nearby directly. It is on the outside case. On top, as mentioned, is the battery management system. We used here a TI chipset, and then these cables can be connected here as an example to the battery directly. So you can see if you have a application which is wired charged right now, this is the case in this drone, it's quite easy to implement a ready-to-go solution. Our kit is the basis of this, what we're talking about. Here we have some added value, some very important points. So we have a sinusoidal current profile, which will have less EMI. We have a resonance frequency as this is working on, and we can changing the output voltage. It can be regulated by the resonance frequency, by changing the frequency. The system itself can be scaled up to several kilowatts, as the full bridge just have to change, let's say, specific parameters or specific components, which we also help you. The zero crossover point will effect to a high efficiency. As mentioned before, we can scale the voltages and currents on the outside, what is needed, and a data transfer between receiver and transmitter is guaranteed with the software, which you can download for free on our websites. The 200 watt kit, or up to 200 watt, we have to say, is possible here to buy in a box. You have the transmitter receiver boards, a power supply, and a load which you have to connect, otherwise it will burn. So as I mentioned, we have the full bridge, our resonance tank with the coils, and an active rectifier. Everything more I would like to point out, please go on our website w-online.de or .com, and then ANP070, this is the application note which is based on this kit. If you would like to download the software and because it's a development kit, yeah, so I appreciate this, that you download the software, do any changes what you want to do, and then you can work on your end. So first of all, as mentioned, you have to go to the website, then fill in some data of you, then you will get an email, and then you are able to download the zip file, which includes all the source codes, the libraries, everything is included, and you can change what you want. Then the next step, you have to go to the Infineon website. At the Infineon website, you have a so-called Dave software. This Dave software looks like here is a screenshot of our software, and you can change the data transfer rates, I don't know, the regulation loop, or what you want to do, or toggle any LEDs. And you need an XMC debugger, which you have to buy. This is not included in the kit, to flash or program the XMC controller on transmitter and receiver side. As I mentioned before, e-bikes, e-scooters, they have normally a different kind of power or battery voltage. For example, not 20 volts as we have on our kit. Maybe they have 36 or 48 volts. This is no problem. We can help you and just give you the BOM, what kind of product you have to change that is applicable for the 48 volt application. Additionally, in these zip files, you will find the GABA files, the layout files, the schematic files, the software itself. But if you want to have the Altium files as the layout and you want to implement it in your system, on your board, for sure, on request, we can provide this. Additionally, if we now look not only on e-bikes, maybe on higher power applications, we have a new coil, which is a little bit bigger. So the mentioned coils before have a square shape size of 50 millimeters. This is a 70 millimeter round shape with the same inductance. So that means no resonant tank changes must be done. You just have to plug and play. But then by changing also some parts on the BOM, you can transfer up to 400 watts with this coil. Coming to the next, we would like to enable industrial IoT because this is what the topic of today. First of all, we need a LCD board. This LCD board is an end-to-end IoT implementation. It is an add-on board. It will not run by themselves, and you need for sure a sensor. A bidirectional data transfer is implemented in this new software. So we need the kit, as I mentioned before. In this kit, we have a receiver board, a transmitter board, the coils. This is just placed in this picture to show the coil. For sure, normally you have to flip the coil, otherwise it will not work. And we have a sensor and a board. In this case, we have our own temperature sensor board here, and we connect it by I2C to our receiver board. And we have our LCD board. We have a new website for that, and you just click on it, and then you will find all informations what you need. Some summary here is this board and this display board. We used a lot of own passive components, capacitors, EMI, Farad beads, LEDs, and so on. And addition, for sure, we use again the same XMC controller from Infineon. It makes the life easier. So mostly components from WE. Display you can program again by yourself. You can download every needed documentation from our website, the application I mentioned already, and you can also go over the online catalog to order it. Also here, if you would like to use the sensor and the LCD board with the 200 watt kit, you have to update the receiver board, the transmitter board, that it will enable the sensor and enable the connection to the LCD board. So you have to go to the website, you have to click on new firmware for transmitter and receiver board, and then you just download the zip file, and with the XMC debugger, you just flash the transmitter and the receiver board. If this is done, I can build up here a system which can directly, for example, measure the temperature and pressure in the room right in my office here, and I can show this on a dashboard. So now I hope it will work. I will change to my, here it is, hopefully it will update. So this is now the live measurement here. So it's not updating the website right now, so I don't know why. Maybe it's stuck, but I can just pick up my camera. Hope this will work. You can see on my desk.
Hey, Alex.
So you can see here on this end here, I have the sensor, the temperature sensor. This is the board, the receiver board with the 2 coils. Then we have the transmitter board with the LCD display. And you can see here the RS232 the connection to our feather wing, which will transfer the signals by Wi-Fi to the second feather wing board. It's here. And I have my mobile, which is here, which is connected as a hotspot to the Wi-Fi here and will send the data to our dashboard, which you have on the screen right now. So like always at live demos, yeah, sometimes it works, sometimes it's not working. I don't know why it's not working right now, but if we just go back to our presentation, as you see there, normally the data will get up and down. I don't know why it's not working right now. Maybe some issues with my mobile. Yes, it's right, because it's not anymore connected. Let's turn it on the hotspot. Now let's see if it's working. Maybe let's wait a second. Okay, I will just continue. If it works, I will just show it again. So I would like to try to explain a little bit more in detail from which were the directly we can see where these data transfers are going. So we will see here by I2C bus, the data will go through the receiver board. They will be in band modulated with ASK, and the back channel is FSK. If you have to regulate the loop by changing the load or by distance changing of the coils, and the frequency will adapt it to all these things around. The UART here on this side will directly transfer the data to the LCD board, and we can have a look on it here. And the UART interface here just bypass them to the wireless node. So these wireless nodes we can use up to 65,000 if you have in a factory, for example, different kind of machines. And with the proprietary WE wireless transfer protocol, data will be safely transferred to the Wi-Fi module. At the Wi-Fi module, it will be sent out just with the standard Wi-Fi protocol to the cloud. And at the cloud, we can show this data on our smart device or mobile devices. The feather wings, which we are using here is the TIO one. It's a gateway, as I mentioned, with the proprietary protocol. This is this board. And the gateway itself is a TION again, plus a Calypso, which sends the data to the cloud. These two, we call it an IIoT enabler. Additionally, for the dashboard, we can help you to create this. We have some examples and web applications for Microsoft or Amazon, and we implement here this, for in this case, this IoT device for WPT. All step-by-step documentation and code examples for this dashboard you can find at GitHub for free, and you can download it there. We have different kind of feather wings which we have developed. So for sensors, different kind of sensors, we have this Tyon 1 as mentioned. Then we have the Calypso for Wi-Fi. We have a power module and a microcontroller module. So all these sensors made a dumb application to a smart IoT application. So you can use the microcontroller, and like Lego, you just click on top and you can just extend or reduce the functionalities. Adafruit and SparkFun, they have hundreds on boards in the market, and you just can combine them as we use the same interface. Our next steps, we have created a new application node to increase the data rate between the transmitter and receiver side. As maybe you remember, I mentioned 500 bits per second in-band data transfer. But if we can use NFC, we can increase the data rate up to 848 kilobits per second. This is possible with our new coil, which we have a combined coil with a wireless power and NFC coil at one part. Middle of this year, so maybe in the next quarter, we should go and we will be ready to have an NFC board, which includes this interface, which will have also the antenna impedance matching on top, and you can combine it like the LCD board with a cable, and you can transfer this data in a higher bandwidth. In the end, maybe if you would like to have a little bit more information about wireless power transfer, we have a topology. Please get in touch with your local sales or FAE contact to get a hard copy. If you need additional help, for sure, you can ask directly in our Q&A session, but also go on our website for wireless power or to the application node website. As mentioned, contact our local Würth Elektronik guys, or you can email to our email address for all these wireless Wi-Fi, GPS, sensoring and topics. We have an own support. It's a WCS-support or digital engineer email address. And just in the end, to give you this email address of the GitHub, where you can download everything according to the dashboards and the feather wings for sure as well. Yeah, I would like to say thank you for your attention and for the opportunity. And Alex, I would like to hand over to you again. Thank you.
Thank you very much. Very interesting.
So, hi everyone. I'm Glenn Konings from Eurofins, Digital Testing Belgium. And following Sam's presentation, I'm going to talk about Qi testing, wireless power charging, and Qi is actually the brand or the logo behind the wireless power consortium. But more will be explained in the next few slides. I would like to start off with the agenda. The topics that I would like to discuss during this presentation. First of all, short introduction of myself, an introduction to Eurofins Digital Testing Belgium, the WPC, why is Qi logo, is that important, and testing, the supported power levels now, when you like to submit a product for Qi. Recently, the WPC released a new specification version, 1.3. I'd like to talk about the major updates for that. Then we also have other WPC standards. I'm going to quickly introduce those. Testing itself, how you can become a WPC member, how you can register a product, and then also the 2 steps in testing, compliance testing at an authorized test lab, and then interoperability testing at one of the 2 interoperability test centers. shortly, I'll talk about some of the hurdles or pitfalls during and after testing that a manufacturer can face when he submits or she submits a product for testing. And then last but not least, some additional services that we can provide to manufacturers as Eurofins Digital Testing Belgium. Okay, who am I? So my name is Glenn Konings. I started working at Eurofins now a little over 9 years ago. At the start of my career, I started as a tester. I immediately got dropped in the whole Qi interoperability testing. And nowadays, I manage the test service. I'm the primary contact if you like to go for testing or if you have any questions related to so. Also because I'm closely, also because I'm, each day I'm involved in Qi testing, so I'm closely following up with the activities within the Wireless Power Consortium. I'm currently the acting IOP team chair, local license co-chair, and part of also other different working groups where all kind of topics are discussed. So I'm also keeping up to speed with all new technologies or activities going on there. Okay, so that's a short introduction about myself. If we then go to Eurofins Digital Testing Belgium, we were the first authorized interoperability test center for Qi in the world. That was in late 2010. Nowadays, there are 2 interoperability test centers, but more of that in the next couple of slides. We helped writing the interop test specification, how for IOCs how to perform the actual test. Being the first, we also have a lot of experience, over 10 years now. And besides Qi, we also do other technologies like USB, HDMI, DisplayPort, SATA, wired technologies. Started in Belgium, and now currently we're servicing the interoperability testing for Qi in Hong Kong. Also more of that later. The advantages of Hong Kong are primarily that it's easy accessible, closely located to other authorized test labs in Hong Kong and Shenzhen. That's where most of the market is right now for wireless charging. Easy shipping, and the guys over there speak fluent English and Chinese. Helps a lot. So that's it for Eurofins Digital Testing. Then the Wireless Power Consortium. So the Wireless Power Consortium is actually the consortium behind the Qi logo and the technology that pretty much now has become the standard for wireless power charging. Mainly because all of the smartphone manufacturers, I could say all of them, maybe a few not, but all of the major ones have implemented Qi and are using Qi in their flagship models. Even now, we see it evolving to mid-range models. WPC consists of about 400 members. Also, it doesn't only get implemented into phones. You, of course, need chargers, and for those, also car manufacturers have their chargers implemented into cars. And IKEA, for example, has it implemented in their furniture. So a lot of manufacturers that have implemented the Qi technology and are making use of that. Currently, we can say that over 11,000 products have received the Qi logo. Not all of them have been tested. Some of them are substantially similar to a tested product. But yeah, it's so that more than 11,000 products carry the Qi logo. And yeah, of those products, a lot of more have been sold, of course. Which makes the next bullet point more than 1 billion fully tested and approved devices sold last year. So that's a huge number. So a huge business as well. But yeah, so that's briefly about the WPC, the consortium. I'd like to talk about the Qi logo and why testing is that important. Of course, there are two key points: safety and compatibility. On the right-hand side, you can see a picture of a product that carries the Qi logo. So consumers can easily refer to that logo when they want to know, okay, is this product safe to use, and will it charge other Qi compatible receivers? In other words, it will work how it's supposed to. If a product is not Qi certified, it may not correctly make use of the foreign object detection, which is a pretty critical thing or must have for wireless chargers, because yeah, if not, if you would introduce a foreign object like paper clip or aluminum foil between a receiver and transmitter, yeah, you would get like the burn marks in the picture below on the right. Not good. You definitely don't want that at your home or in your office. You don't want that anywhere. So that's why it's that important. And the WPC has a specification that is built around safety, compatibility. So yeah, it's really important that products are tested against such specification and built also against such specification. Some online platforms also now only allow Qi certified products to be sold. The WPC is also spearheading that move for online shops to only offer Qi certified products, because yeah, otherwise you will end up in unsafe products and yeah, lawsuits and yeah, you don't want that. Okay, so that's briefly why the Qi logo and testing is that important. I think it's obvious why. Recently, the WPC released a new specification version. They moved from version 1.2.4 to 1.3. Some major improvements to the structure were introduced, but also yeah, many additional compliance tests. Many of them are based on issues that we faced during interoperability testing, which is the last step in testing. So we only receive products that pass compliance testing. So if your product fails interoperability testing, there must be a missing compliance test. So a lot of new compliance tests came out of failures during IoT. Like I mentioned here, and manufacturers can continue to test and register against the previous specification version until 180 days after the release of the version 1.3 specifications, called the so-called grace period. You don't right away have to fulfill all the requirements in 1.3. What I would also like to talk about is an important addition, which is authentication. Authentication between a transmitter and a receiver. It will get particularly relevant if we will go to even higher power than currently 15 watts per Qi, because authentication is all about a charger being able to say, okay, I'm a Qi charger, the receiver to see, oh yeah, he's right. He is a Qi charger. Let's go to a higher power level, because if not, and if you would go to a higher power level, and all the safety and compatibility requirements are not fulfilled, you will end up in in some problems. So that's a major addition to this specification version. Also, when aiming for those higher power levels in the future. Okay. Supported power levels. So I also already mentioned that it now goes up to 15 watts. You have the baseline power profile products that go up to from 0.1, for example, to 5 watts. And then the extended power profile products that go from 5 to 15 watts. Specification also provides a wide range for power transmitter designs, going from A1, what is it now, to A40 now. Also B-type designs. Those are multi-coil designs. Yeah, a lot of coil designs. So manufacturers can really select what design fits their implementation the most and submit it for testing. And also, yeah, it's because the WPC now exists over 12 years now. Those transmitter designs are a build-up of manufacturers submitting new designs to fit their implementation. Okay, so yeah, like I said, as a manufacturer, you can submit a new design, transmitter design. It must then follow the approval scheme, but when approved, it will be added to the specification as an annex, and then in the next major update, officially added to the specification. Part of such approval procedure is that you have to test, have to pass both compliance and interoperability testing. Other WPC standards. So there are currently some new standards evolving. Okay, Qi has been there for quite a while already, but the two other ones are recently emerged, let's say. The Qi cordless kitchen standard is a standard that enables the development of safer, smarter, and more convenient kitchen appliances. Yeah, many of you may already make use of the induction so the cooking with an induction furnace, and this is actually quite similar, but it also focuses to appliances like a water cooker or rice cooker, or any other appliance, mixer, such things like that. It's like I said, it's a standard that is not that recent, and it delivers up to 2,200 watts. Currently, they're about ready to release an official certification program. The specification is already there, but still, they are about to release a certification program, and then members can submit products to be certified according to Qi. The little brother of LEV, wireless charging, so light electrical vehicle. It's an interface, it's a standard that defines future-proof charger and receiver interfaces that support regular and fast charging for light electrical vehicles. I think Sam showed it in his presentation. So like now almost everybody drives an electric bike, you want to charge it, you can easily do so without making any contact via charging stations that work through this technology. But yeah, it's a recent standard, recently emerged standard within the WPC. So a lot investigation still has to take place, and the standard needs to evolve. There's also the industrial wireless charging standard. It's mainly built around robots, unmanned robots. For example, yeah, in the right-hand picture, you can see a drone delivering packages. If you want to charge that drone, you can do so wirelessly, so you don't have any metal contacts that can be exposed to water, condensation or something else. So you really have a more safe charging method. And also, if you don't have any metal contacts, you will also have a product that will be more, it will last a bit longer because you don't have any contacts other than the surface where it's the charger, of course. Okay, so that's about the other WPC standards. Then I'd like to briefly talk about product registration. So if you're a member of the WPC, you can become a member through the WPC website and fill in all the documents and pay your membership fee. Different memberships levels apply. You can submit products for testing. You can do so online and then make all the arrangements with the ATL that tests compliance, and then the IUC that tests interoperability. But the whole uploading of test results and things like that is done online. So if you submit a new product for testing, you'll be assigned with a unique Qi ID number, and that is used throughout the registration procedure. And also when your product is registered, that Qi ID number sticks to your product. Yeah, it's a bit how the process works. The logo license admin, short ELLA, controls everything, the whole process. And like I said, after compliance and interoperability testing, we upload the reports, and then it's finalized and registered if everything is okay. And a member can fully follow that, follow those steps through the WPC members section. What is required when you submit an initial product application? Of course, you need to fill out certain product information, such as transmitter design, potential power or maximum received power level in case of a receiver, support of Samsung's proprietary charging extension, by the way, which is part of the Qi specification, a self-declaration form where you need to fill out exactly that as well, but sign, and for example, stamp. For a lot of Chinese manufacturers, the stamp is the go-to signature. And yeah, of course, pictures of the product that you submit for testing. And also in case of a power transmitter, pictures of the coil and the PCB. The WPC now requires such pictures when they would, if your product is registered and sold, the WPC organizes market inspections to see if the products sold are still the same as what was tested, and a big part of that is also to check the PCB if no other components are used, or a different schematic, or a different coil even. So that's why the WPC now also requires that to be uploaded, and also to check if what you declare as transmitter design, if that fits what you upload as a picture for the client. Sheet certification, so I already mentioned this a few times. So the compliance testing part is the first part in the testing process, and that's being done at an authorized test lab. So you can see here below there are quite a few, but you can also see that quite a few are located in China, a few in the US, in Germany, but yeah, primarily the labs are all, most of the labs are all based in the APAC region. And yeah, that's primarily because most of the manufacturers submitting products for Qi testing manufacture in China or Korea or Japan. Yeah, that's a bit the idea behind it. So it's the first step in the testing process. The authorized test lab will use the approved test system from NOC 9 to check if your product is compliant with the Qi test specification. The compliance test focuses on power delivery, communication of the physical layer and protocol-wise. And yeah, nowadays for 1.3, these tests will also focus on authentication, and of course, a very important one, foreign object detection. Below is a snapshot of such FOD compliance test, where foreign objects are introduced between test power receiver and the transmitter on the test. And then the test power receiver builds up power, requires more and more power. And with the foreign object inserted in between the two, it is then tested if the temperature does not go over 60 degrees. If so, the test fails. Some products are built that they have a heat sensor, and if it goes up to 60 or more, they shut down. They stop power transfer, and they wait when it cools down again to reinitiate. Or some make use of the FOD method that you check what is being received. You check what is being transmitted and then received, and then if there's too much difference in between that, it's also a sign that another object is running with all the power, stealing all the power. So that's also a method of detecting foreign object. And yeah, many other tests are performed depending on the product capabilities. So it depends on what you support that the tests are done. Things to keep in mind when submitting a product for testing, and that's for testing in general, not only for compliance testing. For both compliance and interoperability testing, we make use of a cross-marking to align the products on test power transmitter, for example, or test power, power transmitters from our test bed. So you'll have to ensure to cross-mark all 5 samples that you submit for testing with the respective coil center markings. All 5 samples submitted also need to be identical. It's a big must, because otherwise you'll end up in issues during testing for sure. The required cabling and power adapter, for example, to enable the wireless charging need to be provided. When a power transmitter is to be tested at multiple embedding depths, in case of a subsystem, for example, you have to provide all the respective spacers, so minimal and maximal embedding depth to simulate that. and a user manual if available, how to set up if setup is not that straightforward. And also, yeah, the information about the LED behavior is always useful because if we would come across an issue, for example, during interoperability testing, we can note down, okay, this is the LED behavior. Typically, if it's blinking red, it's a sign of FOD, and that can then easily be communicated to the customer. Interoperability testing. So what we do as a test lab, as an IOC, as I mentioned, we're located in Hong Kong, and after a successful compliance test, we start with interoperability testing. Also, yeah, the interoperability test fee can be directly handled with Eurofins digital testing. Upon a pass result, we upload. Yeah, the product passed all testing, and the result is uploaded. When the result is a fail, unfortunately, the issue must be resolved. And once the issue is resolved, both compliance and interop testing need to be retested. So it's a process that needs to be repeated. So it's sometimes a real burden to manufacturers if they're in a hurry. Yeah, they need to start all over. So I hope that what I'm like to discuss now would help you to prevent such issues. So during interoperability testing, a product must pass 100% of the test bed. So new power receiver, such as a smartphone, is tested against the power transmitter test bed and must pass that test bed entirely, and vice versa. So if a new transmitter is submitted, it must pass against the full power receiver test bed. Even a single issue requires a fix and a full retest on both compliance and interop testing. The hurdles during testing, it's mainly about testbed variation. There are a lot of products in the testbed, now less than in the past, because the WPC was a victim of its own success. Products passing interoperability testing were added to the testbed, but that wasn't possible anymore, so they had to have a different mechanism. Products are now no longer immediately added. For transmitters, only products that are unique of design are added, or products of a new specification version are added. Power receivers do still get added after they are published to the public and sold. This also because there are less receivers being submitted for testing. And also we have a restriction that after 2 years, the product is removed from the testbed, so-called lifetime. The testbed consists of a wide variation of devices. As you can see here below, I've copied here some pictures of typical receivers and transmitters. So you have all types of receivers, smartphones, phone covers, earbud cases, wireless charged mouses, portable speakers. Yeah, a lot of variation, and we now see the trend that there are more and more earbud cases being submitted for testing. It's actually even catching up with the smartphones itself. Yeah, and then for power transmitter testbed, also a large variation. You can, from consumer pads to automotive inline chargers, subsystems that can then be later on integrated in large systems like furniture. Another hurdle during testing is the power adapter. It's a bit ironic, but yeah, the power adapter and the USB cable is key, because your power adapter is not capable of supporting the required power demands or levels, it can cause the product to fail certain compliance tests, or even guaranteed, such as the guaranteed power test, or interoperability against receivers that say, oh, you support, for example, EPP, let's go to that higher power level. But then, if you have a power adapter of 5 volts, 2 amps, you'll never reach that higher power level. So that's very key for products being submitted for testing, power adapter and the cable. So yeah, I would definitely encourage all manufacturers to, when submitting a product, to submit it with the power adapter which it will be sold with, the product. And if you're selling your product without one, to submit it with a capable, good power adapter. You can also contact us if you want to learn more about good power adapters, and then we can fill you in on that. Debugging and fixing issues. On-site debugging, we do support in Hong Kong. And before we did that here in Belgium, but nowadays, as the testbed is over there, we do support on-site debugging, and then manufacturers can then test with the actual failing samples. We can get you in contact with testbed product manufacturers, so that you can test for yourself at your site, and not if you're far away from Hong Kong, and you can still debug with those samples and resubmit your product if you got a fix available. We also, when we report an IoT issue, we use the Qi sniffer tool. It's a quite a handy tool. It's a USB powered device that we bring into the magnetic charging field, and then we log the communication, and then you can see as a manufacturer where it goes wrong. Of course, if you make use of a also different logging tool, we can, if you provide us with a procedure, we can also log the issues via it. So, but that's always provided, the Qi sniffer logs, and typically come very much in handy. So also IoT issues can mainly relate to protocol, power delivery, communication, or no response to a digital ping. So that you actually don't get any response at all. Submitting a request to the WPC to remove a specific testbed product is also a way to get around the issue. If you, for example, have a single issue against the testbed, and you feel that the testbed transmitter is not behaving as it should, you can request to the WPC to remove that product. But then you have to submit a fully documented request on why you think that this product is not functioning as it should and showing undesirable behavior. Pre-interoperability testing is also something that can avoid you running into issues during the official stage. We offer that as a service. We apply the same test procedure. We can apply the same test procedure as during official, or you can ask something completely different. You can ask us to test for 1 minute, for example, instead of a normal 5, or test for other things like usability or end-user experience. There's also the power efficiency aspect that we can check. So that's also part. That's my last slide. So power efficiency, we did that in the past for the WPC, and we checked if we, by use of a certified receiver, if we could by such benchmark certain transmitters on power efficiency. And we would then have the power receiver on specific points over the charging interface and have it to charge from 10 to 90%. And then we would log the average consumption of the power transmitter and the time that it takes to charge up the device from 10 to 90%. And then you can have the power efficiency. So that is a method how we can define actually how efficient your device is. We can compare it to already benchmarked transmitters. So yeah, if you're interested or like to have more information, you can always reach out to me and then we can provide you with such. So yeah, that's about it, I guess. So yeah, if you have more information also on Qi certification, you can go to the WPC website, which is also a very handy website where you can find all information about testing and what to do, and also how to become a member, of course. But like I said, if you have any questions, you can also reach out to me directly via this email address. And I'll be happy to answer any questions or also remarks that you had during this presentation can also be shared by email if you prefer. So yeah, Alex, that was it for me. Hopefully that was that all went smooth.
I think it was. Thank you very much.
Thank you.
Running a bit out of time, so I want to go to the
definitely.
questions quickly. So there are a few questions coming in. First question that was asked is, why are proprietary wireless charging methods allowed to go over 15 watts and Qi is not? I'm not sure who can answer this one best. Maybe you can do that, Sam.
Yeah, for sure I can do. Also, Glenn already mentioned in his presentation that Qi is working on higher power, like the kitchen or LEV or industrial applications. So yeah, so it is not allowed from Qi. It is not ready the standard. So still all the companies are working on it to release standardization. And this is, let's say, always a bigger step. A lot of companies must approve this and release them. And for the proprietary solutions, which, for example, our 200-watt kit, it is for sure here we have a little bit easier way, as it is not like a standard that will work all over the world. It will work over the world, but for maybe Glenn can also add here some points about the certifications. You have to do it for each country, for each regulation groups, different kind of continents, different kind of countries have different kind of regulations in their country, and all these are let's say taking account in the standardization of Qi. If we do a proprietary solution, we do it just for one application, for one appliance, for one customer, for example, and this is much easier. And our, for example, the 200-watt kit is just an easy step into this technology.
Thank you very much. Hope that answered the question. Just to add from my side, the power level is basically as much as you want to or dare to, maybe.
Yes.
The only limitations, of course, is how much power you could effectively transfer over calls and that kind of stuff. But
Right.
yeah, perfect. So that brings us to the other question, and this goes all the way down, because the question here is, how about power modes below 1 watt, for instance? Because we tend to talk about higher power and even more power, but of course a lot of applications are very low power, like those.
Yeah, I will just answer this, Glenn. Maybe you can add on if you want. So lower power is also possible because Qi is up to 5 or 15 watt. That means it's also for 1 watt possible. So does that not mean that's not possible? But if you have this low watts to transfer, here in this case, then also The loosely coupled system from Airfield Alliance could work quite good because here you have the antenna matching, and in the high field, it's not so much power will be transferred, and it will be not so dangerous from the point of view for EMI. And also you can use for sure the new NFC standard, which allows with the NFC antenna at 13.56 megahertz power transfer up to 1 watt. So as you can see, for lower, let's say milliwatts up to 1 watt, there are more possibilities than the induction coupled, closed coupled systems. They give more spatial freedom for your appliance or application.
Okay, great. Glenn, do you want to add something to that?
No, I completely concur with Sam. So yeah, typically for Qi devices, we see that they go up, yeah, that they start off from 1 watt. For example, earbud cases start off from 1 watt and go up to 5 or 15. But yeah, it is possible. That surely yes. Yeah.
Okay, great. Glenn, then I have a question from you. This was asked by me. On your slides, you talked about that there was taking a photo of all the applications that are being certified, just to make sure that nothing changes when they are in the field. My question refers to at the current market situations, there's a lot of shortages of components. If a manufacturer should swap out an existing coil from the current supplier to, let's say, a Würth Elektronik version, which are both A5 coils that are designed for transmission, would that be okay, or does that mean that they still have to recertify it?
In that case, they can always consult with the WPC if they can register that product as a substantial similar product. If it meets certain requirements, it can be the case. So in any doubt, they can always contact me or the WPC directly to see if recertification is needed, just to avoid running into issues during a market inspection.
Okay. I was hoping for a clear no, it's not needed, but
yeah.
it's always with.
Typically, market inspection is there to get all the unsafe products that really cheat and are unsafe from the market. If it's still compliant and interoperable, then the WPC won't take legal steps or something like that. But it's more to just check if what is in the field is still safe to use for end consumers. Yeah.
Okay, perfect. Thank you very much for your answer. Well, that brings us to the end as well. We are run out of time. Again, if you still have any questions that you want to ask but couldn't today for whatever reason, just contact one of us. We are always happy to help you with all your questions. From my side, thank you very much for attending. To both of the speakers, thank you very much for presenting. Very interesting topic, and well, perhaps see you in the next session. Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.